Hi everybody. So here is a video that you've probably seen before, the DVD video logo screensaver. So my particle here, my logo, bounces around the screen, hits the boundary each time and changes direction. Let's look at this in a bit more detail. At the start, my logo is going to have a velocity that goes down to the bottom right. So if I was to write this down, I'm going to have an initial velocity of going this way. So I'm going to say V1 is equal to a positive number in the I direction, and then a negative Q, and then my unit is probably centimeters per second instead of meters per second. So we're going down in this direction. We're going to the right, so positive number for P, and then we're going down to the left. We're going downwards, so a negative number for Q. And my logo is going to travel all the way down here and eventually hit the bottom of the screen. If there was no boundary here, my logo would keep going down this direction. But of course, that doesn't happen, right? So my I direction is going to stay the same. The magnitude of my I component is going to stay the same. But the Q component is going to change sign. Now, in our example here, our coefficient of restitution is 1. So the DVD logo doesn't actually lose any speed as it bounces around the screen. And we'll look at what happens if it did, if E was less than 1 in just a second. But for now, E is going to be 1. So if I let this video roll on a little bit, at this stage here, we're going to have a new velocity, which I'll put in a new color here, which I'm going to call, let's say, V2. So at this stage here, my video is going up in this direction. And V2 now is going to be same magnitude in my I direction. However, I'm going to have a sign change. So this is going to change to be a positive here in my J direction. And then, of course, E is just equal to 1. So it's going to be Pi plus Qj. Then let's see what happens when it bounces off another boundary. Here we'll have a third velocity, which will be, I'll put this in green. So now we're traveling up in this direction when it hits our third boundary. And V3, well, what's happened this time? It's hit a vertical boundary this time. So I'm going to get negative Pi plus Qj to be my third velocity here. So if it hits a horizontal boundary, then I change my Q component, change the sign of my Q component, and multiply by E, which is very nice in this case because it's just 1. And if it hits a vertical boundary, I change the sign of my I component and multiply by E. So we can have a think. What would happen here if I had a value of less than 1 for E? Well, if E is less than 1, then my velocity 1 is going to be the same. My velocity 2 is going to be, well, it's going to be a little bit less than Q, right? So this thing here is actually going to be a little bit less than Q. So this would mean that my magnitude of velocity 2 is going to be less than my magnitude of velocity 1. So it actually got a little bit slower. And then, of course, this is going to mean that my velocity 3 is also going to be a little bit less. Every time it hits a boundary, it loses a little bit of speed. So in this case here, if I had an E multiplied before this would get less and less. So we could think, well, what is our speed against time, knowing that we're going to hit the boundary very rapidly? What would happen if I let E equal 0.9? We're going to lose speed quite slowly. It's never going to be 0, okay? It's never going to be 0, but it's going to get really, really close. So we're going to get decay like this. Kind of slow decay in our speed like this. And then what would happen if we picked a value that was close to 0 for E? So let me pick this green color here. What about if we had E being 0.1? Well, you'll see our speed is really rapidly going to decrease in this case here. So we're going to get really, really rapid decrease. It's going to asymptotically go to zero like this. So we get a really slow DVD logo bouncing around the screen in the end.